Located in the high desert of southeastern Utah is the Crescent Junction disposal site. And what happens here is the culmination of one of the most ambitious environmental cleanup efforts in the American Southwest. This disposal cell site is part of the Moab Uranium Mill Tailings Remedial Action, or UMTRA project, which belongs to the U.S. Department of Energy, or DOE. The Moab UMTRA project was created to protect human health and the environment for generations to come by relocating contaminated materials from a former uranium ore processing facility to an engineered disposal cell. From the banks of the Colorado River to the foot of the Book Cliff Mountains, here's how it all comes together. The story begins roughly 30 miles south near the town of Moab, Utah, where the former Atlas uranium mill left behind approximately 16 million tons of radioactive mill tailings and contaminated material sitting directly on the banks of the Colorado River. The risks were clear: radioactive contamination, proximity to a major water source for millions of Americans, and ongoing groundwater impacts. The materials had to move. Crescent Junction was selected as the permanent disposal site for good reason. The location offers geological stability, including deep, isolating Maine Coast shale bedrock, an arid climate, remote federal land, and critically, access to Union Pacific Rail, making safe, efficient transport possible. The defining feature of the Crescent Junction site is the engineered disposal cell, a multi-layered containment structure built to isolate radioactive and contaminated materials permanently. The cell measures 4,400 feet long by 1,800 feet wide, with tailings placed to a total depth of 50 feet, 25 feet below grade and 25 feet above. It starts with the foundation. Residual radioactive materials, or RRM, are placed into the Maine Coast shale bedrock and built up in controlled, compacted layers. Next, the cover system, with an interim soil layer that protects the compacted tailings during continued cell construction, a 4-foot compacted clay radon barrier that keeps emissions well below regulatory limits, a 2-foot frost layer prevents freeze-thaw damage, and a 10-inch rock and soil cap that resists erosion, deters burrowing animals, and supports native vegetation. Unlike traditional rock armor covers, this evapotranspiration, or ET, cover is designed to work like nature does in arid climates, using native plants and evaporation to pull moisture away from the materials below. This isn't a pile of radioactive dirt. It's a precisely engineered structure built to last for centuries. Moving radioactive contaminated material safely requires seamless coordination from excavation to final placement. At the Moab site, material is excavated, loaded into sealed steel containers, with dust suppression and radiation monitoring systems utilized. Containers are loaded onto Union Pacific rail cars and transported 30 miles north to the Crescent Junction site, a mode of transport chosen for its safety, efficiency, and minimal environmental impact. At Crescent Junction, specialized haul trucks transfer the containers to the disposal cell, where they are emptied inside the cell. Trucks place the material in the designated area. Dozers spread it in precise lifts, and compaction equipment presses each layer to required specifications. Every lift is verified before the next begins. Interim cover controls dust and radon as sections are completed, with environmental monitoring done throughout. Today, the disposal cell is nearing capacity. The finish line is in sight. Completion is projected for 2029, when the final ET cover is finished and the site shifts to long-term surveillance. Over time, native plants will take root across the cell, blending into the high desert landscape, a living testament to responsible environmental stewardship. Under DOE's leadership, the Moab UMTRA team is nearing safe completion of this cleanup, on schedule, safety-focused, and fiscally responsible from start to finish. It's proof that with proper planning, science, and dedication, even the most complex environmental challenges can be solved.